Okay, this is the video for the Study Island topic, Solve Unit Rate Problems. As with all these Study Island topics, you should open up the lesson and read through it. There are a lot of great examples and videos that you can find on the lessons. And for this very first problem, you're going to find some really good help right here on page 3. Let's see what I'm talking about. Number 1 says to draw and use a double number line diagram to model and solve the problem below. So before we even read the problem, what in the world is a double number line diagram? If you look at page 3 of your lesson, you'll see exactly what a double number line diagram is. A double number line diagram is when you have two number lines, one kind of on the top and one on the bottom, and they both represent two different categories. In this particular problem, example number 1, the top line is representative of miles, and the bottom line is representative of the number of gallons of gas it takes to go that many miles. If it takes 8 gallons of gas to go 136 miles, you see that the 8 and the 136 line up with each other. Now, this particular problem asks how many miles you could go with 18 gallons of gas if it takes 8 gallons of gas to go that 136 miles. So you see there's a question mark here. That's an unknown value. And the way that you use the double number line diagram is to find a unit rate and then extrapolate that out. So we're going to go ahead and do that for this first problem. For the first problem, Leah gets to paint her room since she bought a new bedspread set. 2 gallons of paint covers 800 square feet. So right away, 2 gallons of paint covers 800 square feet. How many gallons of paint will Leah need to paint her entire room, which is 1,200 square feet? So let's go ahead and do a double number line diagram. I'll draw a starting point here. So that we have 0, and I'll use the top to be, let's say, gallons of paint, so 0 gallons. And the bottom also starts off at 0, and that is 0 square feet. And I will draw my 2 lines. First one. Here we go. And the bottom one. And we'll put a line on here. Okay, so let's say these are our number lines. We should extend them a bit further. And 0 gallons is right there. Well, how many gallons would this be? In our problem, that is 2 gallons. So we've got 2 gallons right there, and that is 800 square feet. So you got 800 square feet and 2 gallons. They match up. You can see right above each other. Okay, so how do we use this diagram to solve our problem? Well, we need to know how many gallons of paint Leah will need to do 1,200 square feet. So where would 1,200, 1,200 be on this diagram? If this is 800, and you don't have to be as precise as I'm being with measuring it all out. That's not the point of this. But it's obviously going to be past 800 a little ways. So it would be right about here on this number line. This is where 1,200 would be. And right above it would be the number of gallons that we're missing. I'm just going to call that X because that's what we call numbers that we don't know. We call them variables, and I'm going to use the variable X, like using that more than question marks. So now what do we do for this problem? Well, we're going to find a unit rate. Square feet per gallon. How many square feet do you get with 1 gallon? So if you have 800 square feet paired up with 2 gallons, to solve the square feet per gallon, you simply take 800 square feet and divide by 2 gallons. If you want square feet per gallon, you divide square feet by gallons. And so that's what we do here. 800 divided by 2 is 400. So we get 400 square feet per gallon. And I can add those to our number line diagram. 400 would be halfway to 800. So if I go there, it's about right there. So here's my 400 square feet. And right above it would be my 1 gallon. So there's 1. And now we can use that to extrapolate out to 1,200. If I have 1,200 square feet that I'm looking for, and I don't know how many gallons, I start with x over 1,200 is equal to 1 over 400. And now we simply solve our proportion. X divided by 1,200, multiply both sides by 1,200. You get X equals 1 times 1,200 is 1,200, 400 times 1 is 400, 1,200 divided by 400 is 3. So there you go. X equals 3. 3 gallons is your answer. Let's try another problem. Number 2. Mishka is on a long road trip and she averages 75 miles per hour for 3 hours while she's driving on the highway. While she's driving on a side road for 1 hour, she only averages 35 miles per hour. What is the total distance that she covers on her road trip? Okay. So this time they tell us her rate of speed. They give us 2 rates of speed. One's 75 miles per hour for 3 hours. If we travel for 3 hours at 75 miles per hour, the way we calculate how far we've gone is that we say 3 times 75, and that equals 225. So let's write this out with units of measurement. 3 hours times 75 miles per hour is equal to 225 miles. So 225 miles. So for 3 hours, she went 225 miles in those 3 hours. But then when she went to the side roads, what happened? For 1 hour, she averaged 35 miles per hour. Well, that's pretty simple. She went 35 miles per hour for 1 hour, so that's 35 more miles. So again, 1 hour multiplied by 35 miles per hour gives us 35 miles. So that means over a total of 4 hours, she went how far? 260 miles. So now we know her total distance and the total amount of time it took her. So we can calculate her average speed. If we want miles per hour, we do miles per hour, but this isn't asking for any of that. It's just asking for the total distance, and we have 260 miles. Now, if it did ask you for her speed on the trip, we would do 260 divided by 4, and we would get our answer there. Next problem. Number 3. Draw and use a tape diagram to model and solve the problem below. Oh, there's another term, tape diagram. What's a tape diagram? Well, let's look at the lesson. If we go back to the lesson on that 3rd page, scroll down past the example from the double line diagram, we find a tape diagram. A tape diagram, or fraction strip, is an illustration showing the relationship between numbers that looks like segments of tape. Tape diagrams are best used to model ratios when the two quantities have the same units. So let's go ahead and look at what a tape diagram would do for us for this problem. Example number 2 has a ratio of boys to girls in Miss Walker's class is 5 to 8, and there's a total of 39 students. Use the tape diagram to determine how many girls are in the class. So if you look at the example tape diagram, you see 5 sections labeled boys and 8 section labeled girls. And that makes sense because it told us the ratio of boys to girls was 5 to 8. 5 for boys, 8 for girls. So based on the tape diagram, you have 13 sections, 13 of what they call rectangles, these little rectangular sections. And those 13 rectangles have to be a total of 39 students. Well, if the number of rectangles and the number of students are both divided by 13, you get 1 rectangle for 3 students, and that's kind of your unit rate. So let's apply that type of problem to number 3. Number 3, in a soccer league, the ratio of boys to girls is 4 to 6. There are a total of 50 players in the soccer league. Determine how many girls play in the league. So just like the last problem, we're going to have a section for boys and have a section for girls, and then we will assign tape sections to each of them. So here we go, boys and girls. So how many sections do we need for the boys? Well, the ratio is 4:6 with boys to girls. So 4 for the boys, 6 for the girls. So I'll go ahead and mark these off at about a centimeter each. 1, 2, 3, 4. And mark that off. 1, 2, 3, and 4. And then for the girls, they get about 6 centimeters because they get 6 sections. One, 2, 3, 4, 5, and 6. Okay, so there are the sections for the boys and for the girls. And let's remember, it says that there's a total of 50 players. So all of these sections together have to be representative of 50 different players. So how much is each little tape section worth? If all of these together are worth 50 players, well, how many sections are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if we have 10 sections, okay, and those 10 sections make 50 children, 50 kids. How many kids per section? Kids per section is kids divided by sections. So 50 kids divided by the 10 sections gives us our unit rate. 50 divided by 10 is 5, and we get 5 kids per section. Once we know it's 5 kids per section, it's pretty easy to figure out how many sections are there for the girls. 1, 2, 3, 4, 5, 6. If each of these is worth 5, 5, 5, 5, 5, 5, and 5, how many girls is that? Well, it's 5 times 6 pretty clearly. So 5 times 6 equals 30. There are 30 girls. All right. Number 4, Jerry sells dog houses at the city fair. Complete the rate chart below to find how much Jerry earns for selling a certain number of dog houses. So let's take a look at this rate chart. The number of dog houses sold is the top row, and the earnings in dollars, that's how much money he makes, is the bottom row. So this chart says that if he sells 8 dog houses, he makes $40. If he sells 12 dog houses, he makes $60. 16 dog houses gets him $80. 20 dog houses gets him $100. What does 24 dog houses get him? If he makes the same amount for every dog house, that when you divide all these numbers, you should get the same thing. And you're allowed to use a calculator if you want to. Let's find out how much he makes per dog house. How many dollars per dog house? If you want the dollars per dog house, take the dollars, divide by the corresponding number of dog houses. Okay, that word per kind of means divided by. Earnings per dog house, do earnings divided by dog houses. So let's take 100, it's $100, divided by 20 dog houses, because it says $100 from 20 dog houses. 100 divided by 20 is 5. So that means $5 per dog house. All of these other combinations should divide to be the same thing. If we do 80 divided by 16, what do we get? 5. If we do 60 divided by 12, what do we get? 5. If we do 40 divided by 8, what do we get? That's right, 5. So that's $5 per dog house. How do we use that to figure out how much money he makes with 24 dog houses? Well, if every dog house gets him $5 and he sells 24, it's pretty simple. 24 times 5. Every one of those 24 houses gets him $5. 24 times 5 is 120. Now you also may notice that these increments were going up at the same amount. 40 plus 20 is 60, plus 20 is 80, plus 20 is 100, plus another 20 is 120. And that works because they were also going up by the same number of dog houses each time. Plus 4 dog houses, plus 4 dog houses, plus 4 dog houses, plus 4 dog houses. So if there is a constant unit rate, the table will grow in even increments like that. Next problem, number 5. Amy works at a babysitting center. Complete the rate chart below to find out how much Amy earns for babysitting a certain number of hours. So here we go. Same type of problem. 2, 4, 6, 8. Then it jumps to 12. This is not like the last problem. You can't just look at how much it grows by, because all of a sudden it jumps by 4, where all the previous increments were just 2. So we have to go back and divide, find our unit rate, and then apply that. How many dollars per hour? We have dollars on the bottom row, hours on the top row. If you want dollars per hour, do dollars divided by hours. The first says 14 and 2. What is 14 divided by 2? 7. Sure enough, all the rest of these are going to give us the same thing. 28 divided by 4, 7. 42 divided by 6 is going to be 7. And 56 divided by 8, sure enough, that's going to be 7 also. So she earns $7 per hour. If she does that for 12 hours, we have 12 times 7 to get our answer, and it is 84. Number 6. Nicholas sold 20½ pounds of shrimp in 4 hours. So he sells shrimp at a rate of blank pounds of shrimp per hour. So let's just stop right there. It wants pounds of shrimp per hour. How do we find that number? Pounds of shrimp per hour. You see that word per? That tells you how to divide to find your answer. If you want pounds of shrimp per hour, then take pounds of shrimp and divide by hours. How many pounds of shrimp? 20½ How many hours? 4. So divide. 20½ Is it okay if I put 20.5 for 1/2? Absolutely it is. 20.5, that's 20½ divided by 4 gets us to 5.125. Now, up here it says to use numerals instead of words. If necessary, use decimals instead of fractions. So it wants us to use decimals in this. If you didn't know that 1/2 was 0.5, here's a trick. 1 divided by 2 is 1/2, and it gets you 0.5. So if you have 20½ it's clearly 20.5. And then we divide by our 4 that we had, and we have 5.125. So we're going to go ahead and punch that in. 5.125 pounds of shrimp per hour. Next, at this rate, he would sell blank pounds of shrimp in 9 hours. Well, if he knows how much he sells for 1 hour, which is 5.125, that's what we discovered. If we want to know how much he'll sell in 9 hours, we just multiply that by 9. And sure enough, times 9 gets us 46.125. So 46.125. And by the way, 0.125 is equal to 1/8. If you did 1 divided by 8, you get 0.125. That is a very common decimal and a very common fraction conversion. That might be something you want to commit to memory. 0.125 and 1/8 are the same number. Number 7, draw and use a double number line diagram to model and solve the problem below. So we have another double line number diagram like the very first problem in this example video. So let's draw another one. Sam wanted to buy candy for all his friends to share at lunch. 1 pound of chocolates costs $6.95. So we've got a pound of chocolates corresponding with $6.95. But Sam only needs 0.6 of a pound, so 6/10 of a pound. What will the total cost of what will be the total cost for the chocolates Sam buys? So let's go ahead and draw our double line diagram. Okay, so there it is. Hope you don't mind me jumping forward. Step 1, you've got the double number line diagram. They both begin at 0. I labeled the top line with dollars. the bottom line with pounds, and this is LBS, which is the abbreviation for pounds. And then $6.95 corresponds with 1 pound. Now, in this problem, Sam doesn't want a whole pound. He wants 0.6 of a pound. That's 6/10 of a pound. So where would 6/10 of a pound be? A little bit more than halfway. You don't have to be perfect with this. 6/10 of a pound is going to be right around here somewhere. So 0.6. And how much money does that correspond with? That's the question. And I'll go ahead and use an X for that because that's a number we don't know. And we use variables to represent numbers we don't know. So now I just have to solve this problem. I've got X that corresponds with 0.6. So I can write X over 0.6 is equal to $6.95 over 1. So $6, 6.95 over 1. That's how you write your proportion for these things, okay? Pretend like there's fractions there and write an equal sign. Now, it says X divided by 0.6. That's what a fraction is. It's a division problem. So if I have X divided by 0.6 and I just want X, I multiply by 0.6. And that cancels the 0.6's out, and I'm left with just X. But if I do it to one side of an equation, I must do it to the other. So I have 6.95 over 1, which is just 6.95, because anything over 1 just remains the same. And I'm going to multiply that by 0.6. So this is just 0.6 times 6.95. I could put them both over 1, but that's kind of meaningless. All you have to do is punch into your calculator 6.95, $6.95 times 0.6, and you get your answer, which is 4.17. So that ends up being $4.17. There you go. Number 8, how long will it take Pablo to bike 56 miles if he is biking at a speed of 7 miles per hour? Well, 7 miles per hour, and he needs to get to 56 miles. How do we do that problem? Well, if you have 56 miles and you want to break that up into chunks of 7 miles, what kind of problem is that? That's a division problem. 56 miles divided by 7 miles per hour will give you an answer. 56 divided by 7 is 8 hours. So there you go. 56 miles divided by 7 miles per hour is 8 hours. Now, if you want to set that up as a proportion, here's how you do so. You are missing h. H is hours. So I'll write the variable h. Now, that number of hours corresponds with some distance, which in this case is 56 miles. So 56 miles for h hours. We don't know how many hours that is. Should be equal to the fraction that is equal to your unit rate. Now, your unit rate is 7 miles per hour. So that's 1 hour over 7 miles. Now, why did I put 1 hour over 7 miles instead of 7 miles over 1 hour? As I'm setting up a proportion, you need to match up your units. Notice that both the numerators represent hours and both the denominators represent miles. Because I started with my variable in the numerator and it was hours, I had to put the 1, which when you have 7 and 1, 7 miles and 1 hour, I had to put the 1 hour in the numerator also so that they matched up. Now I can solve this by multiplying both sides by 56. That cancels out the 56 on the left side, leaves me with just h. And on the right side, what do I get? Times 56, which if you want to make 56 into a fraction is 56 over 1. Oh, and by the way, this was miles, so the units miles cancels out. And this is miles, so the unit miles cancel out. Well, what happens here? We have 1 hour times 56, which is just 56, over 7. 56 over 7 is 8, so that you get your 8. And the unit left is hours, so there's your hours. So 8 hours. So 2 different ways to think about the problem. Both of them get you to the same answer, which is 8 hours. Number 9. Albert is traveling 40 miles per hour in his car. After 5 hours, how far will he have traveled? So if you want to set up a proportion for this, you can. Here we go. 40 miles per hour. After 5 hours, how far will he have traveled? That is a distance. So let's go ahead and make my variable for this problem d for distance. D for distance is going to pair up with 5 hours in this problem. So 5 hours. And that has to be equal to my unit rate, which is 40 miles per hour. Now, D is distance, and if I have 40 miles per hour, that's 40 miles paired with 1 hour. So what should the numerator for this be? The miles or the hours? Well, my other numerator was a distance, which is going to be measured in miles. So this numerator should be distance also. So it's going to be 40 miles over 1 hour. So notice again, the numerators are both miles. The denominators are both hours. That's how you know you're writing your proportion correctly. They should match up like that. So now I can solve for my variable d, multiply by 5 on both sides, because right now it says d divided by 5 hours. So you multiply by 5 hours. The 5 hours cancel. Of course, if you multiply one side of an equation by 5 hours, you have to do the same thing to the other side. So times 5 hours, which I can write as 5 hours over 1. And here we go. The hour cancel out. And we have 40 times 5. 40 miles times 5 is 200 miles. And that's your answer. All right, last one. Number 10. Driving 70 miles per hour, it takes Alicia 3 hours to reach the airport to go on vacation. It then takes her 3 hours to get to her destination with the jet traveling at a speed of 450 miles per hour. How many miles does Alicia travel to get to her destination? So we're just calculating total miles that she drives and total miles that she flies and adding them together. So let's start with driving. She drives 70 miles per hour for 3 hours. So we've got 70 times 3, 70 miles per hour times 3 hours is 210. Let's go ahead and write that with the units. I've got 70 miles per hour multiplied by 3 hours is going to be 210 miles. So that's the car. This is the car. Now, what about the plane? It says it takes her 3 hours to get to her destination with the jet traveling at a speed of 450 miles per hour. So now let's do the jet. The jet moves at 450 miles per hour for 3 hours. 450 times 3. 450 times 3 is 1,350. So we have 1,350 miles that the jet travels. Okay, 400 times 3 is 1,200, and 50 times 3 is 150. 1,250 plus 150 is 1,350. So this is what we're looking at here. We got the car at 210 miles. We have the jet at 1,350 miles. Adding them together, we should get our answer, and we get a total of 6 hours, and 1,350 plus 210 is 1,560 miles. And she did that all in 6 hours. And that's it. Again, remember to read through the lesson and watch the resource video in there. Work hard. Good luck.